solving one-step equations and solving two-step equations. I'm going to start with how the order of operations works, solving an equation forward, and then try and gain an understanding of how that's working to solve it backwards, and that would be solving an equation when something's missing. So the example I'm going to use is 2 times 3 equals 6. That means we have the number 3 and we multiplied it by 2, which means we doubled it. So that means we have two groups of 3. Two groups of 3 will give you 6. 3 plus 3 is 6. So 6 equals 6. That's true. Now, what if the 3's gone and we don't know what it is? 2 times something equals 6. Okay, well, if we multiplied that something by 2 and it ended up being 6, well, what did I do? Okay, I doubled it. So if I doubled it to get 6, that means I have to cut it in half to get back to where it was, right? So that's when we're multiplying something by 2, we divide it by 2. Dividing something by 2 is the same thing as taking half of something. So whenever we take half of something we multiplied by 2, it goes back to itself, which is why this is a big 1. 1 times whatever we were doing. So this all comes down, and we're left with, look at that, a single question mark. 1 question mark equals 6 divided by 2 equals 3. Now the only difference in using a question mark versus a letter to represent what we're missing is just, any letter you want, and it's called a variable. So x, y, z, etc. So whenever you're solving something forward, like 2 times 3 equals 6, parentheses, exponents, multiplication, division, addition, subtraction. Whenever you want to undo it, you undo PEMDAS. Which is why, when we get into two-step equations, we always start with adding and subtracting. So what I'm going to do is go through each of these problems using the 4 bullet points and just check the work as it's going through. The whole purpose behind this is to get into a routine of how to solve two-step equations. The math is not going to be difficult. It's just getting into the routine of writing, rewriting, writing, and rewriting. So always start by dividing the problem in half where the equal sign is at, because that's where we have the balance happening. What happens to one side has to happen to the other. Think of it like a sideways fraction. So add, subtract. Do you see any addition or subtraction? Yep. So I'm going to write down what I see and what its opposite is. And I'm going to circle it. And I'm going to do that to both sides of my line. So the whole purpose behind doing the inverse operation of addition subtraction is to get rid of the number. This turns into 0. Positive 3 minus 3 is 0. You don't need to rewrite 0, but you do need to bring down what's left over. I like to mark it out. That way I can see what's left on that side, and then I just rewrite it. 9 minus 3 is 6. So look at that. We're back to where that one-step equation was I used in the example. This is called rewriting. So whenever you do an operation or undo an operation and then you rewrite the problem, that's what I'm going to call a rewrite. The next step would be, do you see multiplication or division? A number next to a letter means multiplication. So I'm going to put times 2. If you want to use parentheses to represent multiplication, that's cool. I would avoid using x to represent multiplication since we're dealing with x in a problem. Write the opposite of it, divided by 2. It's inverse. That's going to give you your 1x like we described in the preview problem. 6 divided by 2 is 3. I think it's highly advisable to take your answer, put it back into the problem just to check. Here's what that would look like. So we know that's 2 times x. In this case, we say x is 3. So all I'm doing is rewriting the problem with my answer put into it. This is where PEMDAS takes place because we do not have anything missing, so we can solve the problem like normal. Parentheses, yes. Is there anything to do inside? No. Do we see any exponents? No. Multiplication or division? Yes. So 6, and then I'm rewriting. And you can see here, addition, subtraction, yes. So then 9 equals 9. This is proof that our answer is correct. Second problem. Divide it in half. Do I see any addition or subtraction? Yes. Adding 1. What's its inverse? Minus 1. I'm going to circle it because that's what I'm going to rewrite on both sides. Whenever I do inverse operations with adding and subtracting, it's always 0. That's why I'm just going to mark it out like that. I'm going to rewrite what I didn't mark out. 2x equals 3 minus 1 is 2. I just rewrote right there. Multiply, divide. Do I see any of that? Yeah, I see a number next to a letter. So typically whenever you're going to be looking at an equation and you're trying to solve it and find a missing number, you're always going to look on the side with the letter. So if there's letters on both sides, that's when we get into multi-step, but we're not there yet. So whenever you see a letter on one side, that's going to tell you what you need to do. The other side is the side you do the math on. So we see a number next to a letter. That number next to a letter means multiply. So that tells us that we need to work backwards by dividing by 2. I'm going to circle it. And I'm going to rewrite it on both sides of my line. This gives us the 1x by itself. 2 divided by 2 is 1. Let's check it. 2 times 1, because a number next to a letter means multiply, plus 1 equals 3. Multiplication comes before addition. 2 plus 1 equals 3. Addition, 3 equals 3. And we are right again. So this one looks a little bit different, but we still start with the same process. Do you see any adding or subtracting? Yes. See subtracting. Its inverse is plus 3. So plus 3 plus 3 to both sides of the equal sign. So again, whenever we start with addition, subtraction, and we find its inverse, it's always going to be 0. Negative 3 plus 3 is going to be 0. I'm bringing down what I didn't mark out. X divided by 3 equals 4. There it is, rewriting. Do you see any multiplication or division? Well, I see a letter on that side, on the left, right here. So that means that's going to tell me what's going on. All right, so x divided by 3. Okay, so divided by 3. Inverse operation would be multiply by 3. That's what I'm going to do. So if you divide something into 3 parts and then you end up multiplying it by 3, you end up with 1/3, 1/3, and 1/3. And you put them all together, you got 3/3. That's why it equals 1. So we're left with x equals 4 times 3, 12. All right, so we're saying our answer is 12. Let's go ahead and just put it back into the original problem and see if it makes sense. 12 divided by 3 minus 3 equals 1. So division comes before subtraction. So 12 divided by 3 is 4. Minus 3 equals 1. Hey, 4 minus 3 does equal 1. 1 equals 1. Look at that. All right. Again, looks very similar. Just switching the numbers up a little bit. Start with the same process. Cut the problem in half. Identify addition, subtraction. We're identifying everything that has the side of the letter on it right now. So we see plus 1. The inverse is minus 1. Minus 1, minus 1. Plus 1, minus 1. So you gain 1, you lose 1, you're back to 0. Bring down what we didn't mark out. Solve the problem. So the side without the letter is where the math is taking place. 4 minus 1 is 3. There's my rewrite. Do you see any multiplication or division? I see a side with a letter on it. It looks like a fraction. Fractions mean division. Inverse is times 4. So there it goes, having 1/4 4 times, which makes 4/4, which equals 1. There's our 1x equals 12. Let's check it. 12 divided by 4 plus 1 equals 4. Division comes before addition, since we're solving PEMDAS from P all the way down to S. So 12 divided by 4 is 3 plus 1 equals 4. 3 plus 1, 4 equals 4. Sweet. divide the problem in half. Do you see any addition or subtraction? So I'm looking on the side with a letter. That shows me both operations. The reason that this is a two-step equation is because we have a division and we have addition. I see addition, plus 1. Inverse, minus 1. Minus 1 on both sides. Keeping it balanced. It's an equation. Equal. Positive 1, take away 1. You have 1, you take away 1, you're down to 0. Bring down what we did not mark out. 5 minus 1 is 4. So the side without the letter is the one we did the math on. There's the rewrite. All right, do I see any multiplication or division? I see a fraction, the side with a letter on it. That means division, divide by 3. The inverse is times 3. All right, times 3 times 3, both sides. That'll give me my 3/3, which is give me 1x, and then 4 times 3 is 12. Let's put it back into the problem, see if it's right. 12 divided by 3 plus 1 equals 5. Division comes before addition. 12 divided by 3, 4 plus 1 equals 5. 4 plus 1, 5 equals 5. There's no reason why you can't confirm your answer as being correct. There's simple mistakes, especially when you start including negatives. So if this answer was negative 12, and then you did negative 12 divided by 3, then you'd get negative 4 plus 1, and you'd have 3. Negative 3 equals 5. And you'd be sitting there going, hold on, that's not true. And then that'll help you sort out where you went wrong in your problem, and you can resolve it. All right, starting off, cutting the problem in half. Do you see any addition or subtraction? Looking on the side with the letter tells me where my operations are. Division and addition. Do I see addition? Yes, plus 2. Inverse, minus 2. So minus 2, minus 2. Okay, and you have 2 and you take 2 away. It's going to give you 0. Bringing down what I didn't mark out. 6 minus 2, the side without the letters where the math is at. 4. There's my rewrite. My new problem, a one-step equation. Now do I see any multiplication or division? Well, I see on the side with the letter that it looks like a fraction. I know that fractions mean division. So I cut something up into 3 pieces. So whenever I want to undo that, I multiply it by 3, and then I'll have those 3 pieces all back together. 3/3 equals 1, and then I'll have x equals 12. You're like, why does these keep on equaling 12? Oh my God. Let's put it back in. 12 divided by 3 plus 2 equals 6. Division comes before addition, so that would mean that 12 divided by 3 is 4, plus 2 equals 6. 4 plus 2 is 6 equals 6. Hey, all right. Right again. Cut the problem in half. Any addition, subtraction? Well, I'm going to look on the side with the letter. I see both my operations. I see division and addition. So yeah, I see addition. I'm going to do its inverse since I see a letter in the problem. All right, so minus 1, minus 1. I have 1 and I take 1 away. It gives me nothing. I'm going to bring down what I didn't mark out. And I'm going to solve the side that doesn't have the letter. That's where the math is at. 4 minus 1 is 3. I'm going to rewrite. Do you see any multiplication or division? Well, I'm going to look on the side with the letter. I see the fraction. Fractions mean division, dividing by 4. Inverse, multiply by 4. So I'm going to multiply by 4, multiply by 4. Anytime I have something cut into 4 pieces and I multiply it by 4, that means I have 4 pieces of 1/4, giving me 4/4, which is 1. Here's my 1x right there. 3 times 4 is 12. 12. Let's put the answer back into the problem, see if it checks out. 12 divided by 4, since division comes before addition, 12 divided by 4 is 3 plus 1 is 4. 3 plus 1, 4 equals 4. Man, I'm on a roll tonight. All right. Whoa, 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 whoa. This one looks different. All right, hold on. I know what to do. All right, do I see any adding or subtracting? There's 2 ways you can think about this. There you see a 1 plus. You can interpret that as plus 1. You'd be exactly correct. If there was a negative in front of this, you could say it's plus -1. You're still correct. Now, the idea behind it is opposite operations, not opposite number. So Whenever you see a plus a -1, you'd end up writing minus -1. So if you're adding a -1, the inverse of that is taking away a -1. So don't confuse negatives with operations. This says +1. There's no denying that. All right, so we're adding 1 on to x divided by 4, and somehow we get 4. Okay, so yeah, I do see add and subtract. I see an addition sign right there. And I know that I'm not going to be adding the x plus 4, or x divided by 4. So that's the division part. So we can automatically eliminate that that's what we're adding. So the inverse would be this. And whenever you want to think about what you do first with adding and subtracting, you're trying to get rid of the thing that's just the number on the side with the letter. So how do I get rid of 1? I take away 1. And look, and that's also the opposite of adding 1. So when I have 1 and I take away 1, I have 0. Drop down what I didn't mark out. Solve on the side that doesn't have the letter. 4 minus 1 is 3. Look at that. Did my rewrite. Now I'm down to a one-step equation. It looks all normal again. All right, so I'm looking on the side with a letter. I see it looks like a fraction. That looks like dividing by 4. Inverse is multiply by 4. So times 4 times 4. So I cut something into 4 pieces. That means I have 1/4 4 times. 1/4, 1/4, 1/4, 1/4. Giving me 4/4, which is the same thing as 1. There's my 1x right there. So 3 times 4 is 12. Cool. All right. So apparently I cut 12 up into 4 pieces and then added 1 to it. Let's see if that's true. I'm going to go ahead and put 12 in for x. So 1 plus 12 divided by 4 equals 4. Division comes before addition, so I'm going to do the division first. 1 plus 12 divided by 4 is 3. 1 plus 3 is 4 equals 4. So just kind of switching gears a little bit on the last one, but you can see the concept is still the same. You're identifying where both of the operations are, and you're undoing them by reversing PEMDAS. So the idea behind all of this is having a strong foundation in order of operations so you can reverse them and figure out what's missing inside of a problem that you'd normally solve going forward.